Hey gang, Mr. Spencer here. We've been talking a lot about how to take information on graphs and use that to make some predictions. Now, one of the things that we've talked about is how to make a line of best fit. And most of the stuff that we've done has been the very simple linear y equals mx plus b stuff. And I want to show you a really important tool that helps with this. We're going to use Desmos, and I think a lot of you are familiar with Desmos as like a calculator, but I want to show you how we can use it in our science classes. So here's what we're going to do. Let's pretend that we are doing an experiment where we are testing someone's walking speed, and we're going to make a position versus time graph out of that. So what we have here is every 2 seconds, we're measuring the position of somebody away from a certain point. Okay, and I've got this this table here. What I want to do is I want to put that into Desmos and have Desmos do the heavy lifting for me to make the y equals mx plus b, and then we want to make sure that we make some sense out of that. So what I do here is over here, this is the Desmos website, desmos.com. It's also going to look very similar on the Desmos iPad app. So you can use either one. But let me show you some of the finer things that we need to do with this. And I'm going to go over here. And when you open up a new graph, what you do is you go in this upper right, or that would be upper left hand corner, and hit the plus. And what you're going to do here is you're going to add a table. Okay, so I'm going to add a table, and you'll notice that it has x sub 1 and y sub 1. We can't really change that. So like over here in this, we have time for the x, position for the y. Once again, we can't change that label, at least not that I know of. So we're just going to assume that time is the x sub 1, position is the y sub 1. So let's go in here and let's add that. So we've got 0, time equals 0, we're at the 2.5 meter position. After 2 seconds, we're at 5.6 meters. 4 seconds, we're at 8.4. 6 seconds, we're at 11.5 meters, and after 8 seconds, we're at 14.7. And what you'll see here, and I'm going to open this up a little bit, so hopefully you can see that a little better. It goes and it plots these points, all right? But we want to do more than just plot the points. What we want to do is we want to find that line of best fit. So what we do is next we go in here and we add an item. In this case, we're going to add an expression, so f of x. And we're going to find out if this works, if it's above or below. What we need to do is make sure that this is, that it fits the equation. So this is pretty linear. So we're going to use the old y equals mx plus b. It would be great if we could just do y equals mx plus b, but that would make it too easy. What we have to do is we have to be very specific about which y we're talking about. So here what we do is we put y1. Okay, so that's going to be this one. And then I wish I could explain why this is, but we use the little squiggly. I think it's called a tilde. All right, but don't use the equal signs on that. And then m, which is for our slope, and then x1 plus b. All right, and here's where that helps. So what it does here is it takes that, it puts a line through all this computer magic that is through this point on average, and it lets us know that the slope of this, okay, so y sub 1, m, x sub 1 plus b, the slope, so m, so the change in position divided by the change in time, is about 1.5. All right, and the other thing that's important is this b value, okay, that's our y-intercept. That's going to be right here. That's where our line crosses the y-intercept. Okay, that's 2.48, so like 2.5-ish. But let's think about what this means in real world terms. So y sub 1, remember, that is going to be our position. So position is equal to, well, m, which is our slope, and we know that the slope is 1.5-ish. Okay, well, think about what that means, though. So slope is rise divided by run. So our rise here, that is our position. So that's going to be meters. And then our run, so our side to side here, that is time. So it's going to be meters divided by seconds. So what this is saying is that our slope is 2.5 or 2.48 meters for every second. All right. And then in our y equals mx plus b, x1, that's our time. And b is the y-intercept, which we saw is about 2.48. And in terms of like real world stuff, let's think about what the y-intercept means. Well, at where it crosses the y-axis, that's when time equals 0. So it's saying at time equals 0, the walker's location is 2.48 or 2.5 meters away. So really what we have in our real world example of y equals mx plus b, what we have is our position is equal to 2.58 meters per second times x, which is time, plus 2.5 meters. All right. So then you can use that to be able to make any calculations, any extrapolation, stuff like that. I hope this helps. There's probably multiple ways of doing this, but this is the way that I've gotten used to it using Desmos. So hopefully that helps. Let me know if you have any questions. Oh man, gang, I am back because I have some really good news. I just went through all the ways that you could go in and add that line of best fit. Come to find out, over the summer or sometime, the nice people at Desmos went in and they made it easier for us to do. So all you have to do is just put in your table just like so. And then go over here and see this lovely little thing that has a bunch of dots and a line going through it. That's supposed to be a line of best fit, also known as a regression line. So if I click on that, boom, right there. Okay, instead of having to type in y1 and then the tilde and all that fun stuff, Desmos has made it a lot easier for us, and the equation is right there. Now, this is linear, so that makes it easier that's if it was, something else like a quadratic or any of those kind of things, we would fit that. But we're not talking about that right now. So here's the equation. Same thing as before, just easier. So remember, here it has y equals 1.5x plus 2.48. Think about what that means in the real world. On our graph, y is the position. Okay, so the position is equal to 1.5. Well, 1.5 what? Well, when we make the slope, that's meters divided by seconds. So 1.5 meters per second times x, which is our time, plus 2.48. Well, what is that 2.48? Well, that 2.48 is the y-intercept, which means that at time equals 0, this person is starting 2.48 meters in front of this position. Anyways, long story short, you have multiple ways to find this regression line or line of best fit, but this one happens to be a lot easier.